What's up? I'm Vin, and today I want to focus on taking the square root of negative numbers. And the main idea for these questions is that the square root of -1 is equal to I, where I is the imaginary number. So we're simplifying radicals here, but we're going to use this idea throughout. So the square root of 300, I could break this down as the square root of -1 times the square root of 100 times the square root of 3. And now the square root of -1 is I, so I have I times the square root of 100 is 10 times the square root of 3. So this is equal to 10I radical 3. So we're going with choice 3 here. For question 2, we have this expression, and we could break this down. We could break this down to the square root of 16 times the square root of -1 times the square root of 5. And just looking at this, I see that 16 times 5 is equal to 80. And remember, when we're factoring radical expressions here, we want to pick perfect square factors. So now this is just going to simplify to 3/4 times the square root of 16 is 4 times I, that's the square root of -1, times radical 5. And now 4 over 4 cancels, and this is going to leave us with 3I radical 5, which is going to make our answer here choice 1. So looking at this expression here, we have the square root of -180x to the 16. And for this question here, what I would do is I would break this down to, first I'll start with 180. That's 36 times 5. And 36 is the biggest perfect square factor of 180. And then we have the -1, and now we have the square root of x to the 16. So now we start simplifying this. The square root of 36 is equal to 6. Then we have radical 5. The square root of -1 is I. And now we have the square root of x to the 16. But just know the square root of x to the 16, we could write this as a rational exponent. That's x to the 16 over 2, because this is a square root. So now we just simplify that. That's going to be 16 divided by 2 is 8. So our final answer here, if we just look for it, is 6x to the 8 I radical 5. That's going to be choice 4. Question 4, we're going to use the same strategy as before. So the top square root of -50 we'll write as square root 25 times square root -1 times square root 2, since the product of these three numbers will bring us back to -50 on the inside. And then we have square root of 2 on bottom. And right away I can see these factors are going to cancel. And then the square root of 25 is 5, and the square root of -1 is I. So we have 5I, choice 3. So same strategy as the other examples. We're going to rewrite the top as the square root of 4 times the square root of -1 times the square root of 5, because the product of those three numbers brings us back to -20. And now we have square root of 5 on bottom, which is going to cancel that square root 5 factor on top. And now we just simplify. The square root of 4 is 2. The square root of -1 is I. So this is going to be choice 2. So question 6, we're going to simplify this. And the top, we could write this as the square root of 36 times the square root of -1 over, and this is already a perfect square on bottom, so I have the minus sign here, and the square root of 4 is just 2. And now we could simplify the top. The square root of 36 is 6. The square root of -1 is I, and we're dividing by -2. And now we just say 6 divided by -2 is -3. So this is going to be -3I, choice 2. Question 7, we could just rewrite the top here. The square root of -36, we're just going to say is 6I. And then on bottom, we have negative square root 36, which is different than what we have on top. The minus is on the outside. So we just leave the minus there, and then the square root of 36 is 6. So now this is going to simplify. 6 over 6 cancels, and I divided by -1 is -I. So we're going with choice 3. Question 8, we're simplifying this expression here, and the square root of -9 is 3I. And the square root of -16 is 4I. All right, note that those two numbers are perfect squares. So then we multiply this. 3 times 4 is 12. I times I is I squared. And we should know I squared is equal to -1. And the idea behind that is that the square root of -1 is equal to I. So if we square both sides, that gives us I squared equals -1. So then what we have is 12 times -1. And this is going to simplify to -12. So that's our solution to 8. For question 9, we're simplifying this expression. So when we want to take a negative out of a radical, we could bring it out as the imaginary number I. And now we have I radical 3, that's the first term here, times the square root of 4 is 2, and to take that negative out, it's going to come out as an I. So now what we have is we have I times I is I squared, and then we have 2 times radical 3 is 2 radical 3. And remember what we said before, I squared equals negative 1. So we have negative 1 times 2 radical 3, which is negative 2 radical 3. And that's our solution to question 9. So question 10 has a little bit more algebra involved. We want the product of this number and this number. But just know here, we could simplify this first. This is 5 plus, and the square root of negative 36 is 6i. So we're going to rewrite it like this. And then we have 1 minus the square root of negative 49 is 7i. So now we're just going to expand this out. And we'll do this without a calculator. We have 5 times 1 is 5. Then we have 5 times negative 7i. We're just going to multiply the numbers. 5 times negative 7 is negative 35. And the I tags along. And then we have 6i times 1 is 6i. And then 6i times negative 7i is negative 42i squared. So now we're going to use the idea again that I squared is equal to negative 1. And what we have is this is going to give us 5, and then we could combine the imaginary components here. Negative 35 plus 6 is negative 29i. So, negative 35i plus 6i is negative 29i. And then we have minus 42 times, remember that's equal to negative 1. And negative 42 times negative 1 is positive 42. So now we just add the real numbers together. 5 plus 42 is 47, and that's going to give us 47 minus 29i. So our solution here is choice 4. So last question here, we're going to express this product in the form a plus bi. So same idea as question 10. We have 2 plus the square root of negative 9 is 3i. And then we have 3 minus the square root of negative 16 is 4i. So now we're going to multiply these two binomials together. We have 2 times 3 is 6. 2 times negative 4i gives us minus 8i. And then we have 3i times 3 is 9i. And then 3i times negative 4i gives us negative 12i squared. And once again, this is a repetitive idea. I squared equals negative 1. So what we could do is we could combine these imaginary components. We have 6 minus 8i plus 9i is plus 1i, or just plus I. And then we have negative 12 times I squared is negative 1, which gives us plus 12 because we have negative 12 times negative 1. And that's going to equal, we have 18 plus I, because we're doing 6 plus 12. And notice they said to write it in the form a plus bi. And be mindful, A represents the real part and BI represents the imaginary part. So our solution here, 18 plus I, is in the correct form.